Okay, college algebra again. Most of the word problems are gone. We're going to do the top of page 3 and the bottom of page 5. And everything in the middle is just not there. Okay, so solving exponential equations. Right now, the only way we'll learn more techniques to do this later. But for now, if two things are equal and they have an equal base, they also have an equal exponent. Two things are equal and they have an equal exponent, they also have an equal base, as long as there's a variable involved. Once that's done, so you set the one that doesn't have a variable, make sure that they're equal so that you can set the rest of the equation equal to itself. And then you solve for x. So looking at number 1, it's 1/3 to the x equals 81. I usually don't like dealing with fractions in the base. This is 3 to the negative first power to the x equals 81. And power to a power we multiply. 3 to the negative x equals 81. So since I have x in my exponent, I want my bases to be equal, which means I would like to turn 81 into a power of 3. And if I can't do that, try to turn them both into some other power. Thankfully, 81 is 3 to the 4th. So if the equations are equal and the bases are equal, then the exponents are also equal, so I can set them equal to each other. Negative x equals 4, so that means x equals negative 4. Not so bad. Now sometimes you've got more than one x. 2 to the x plus 4 equals 8 to the x minus 6. Okay, again, x is in the exponent, so I need to get the bases equal. I can turn 8 into something in terms of 2. 8 is 2 cubed. Distribute the 3. It's important, it goes to both terms. 2 to the 3x minus 18. And again, just like the first one, the bases are equal and the equations are equal, then the exponents are also equal. Then get all my x's to one side. I'm going to get them to the right side. So 4 equals 2x minus 18. Add the 18. So 22 equals 2x. 22 is equal to 2x. We divide both sides by 2, and we get x equals 11. That one's not super different from the one that came before it. However, number 3 is x to the negative 4/3 equals 81. A few ways to go about this. Since the x is in the base, I need my exponents to be equal. How can I deal with this? I think the easiest way to do it is to call this the cube root of x to the negative 4th equals 81. Now we know from the first problem that 81 is actually 3 to the 4th power, because we did this over here. But that's not the same power as the negative 4th power. If I'm going to do that, then I really need it to either both be positive 4th power for this to work. So how do I turn a negative into a positive? I flip this. So I said 1 over the cube root of x to the positive 4th equals 3 to the 4th. Flip to the reciprocal to the negative 1st power. Now, something that has to happen here, because this is an even root, and there is an x involved into the equation, when I take the 4th root here, I need a plus or minus 3. Well, that's just how it has to work, because again, negative and positive numbers raised to an even power are both positive. I would rather my x be in the numerator. If I flip this side, then I also have to flip that side. So the cube root of x equals plus or minus 1/3. Now how do I get rid of cube root? I cube both sides. So that means x equals, raising a negative to an odd power is still negative, so I still need a plus or minus 127. None of the problems should be any harder than that one is. Now, at the bottom of page 5, it describes some transformations. These are generally helpful for you when graphing, to figure out how the graphs will work. Describe the transformations from their parent function. So if you see f of x equals 3 to the x plus 1 minus 2, the parent function is 3 to the x. So when a plus 1 is coupled with x, that's when it moves left or right, and it always goes the opposite direction. So going right 1 would be minus 1. We have a plus 1, so this would go left 1. So that's just a quick rundown. Now again, just adding or subtracting something at the end is when it moves your y value up or down. Minus moves it down. So in total, 3 to the x plus 1 minus 2 generally is left 1, and then it's down 2. Not too bad. It works the same as transformations worked before. It's just where the numbers go looks slightly different. For number 2, negative 4 times 2 to the x minus 3 plus 1. A negative multiplied in front of everything is going to do what? So we start with 2 to the x. We have a vertical reflection because of the negative, just like on all the other things. That's negative 2 to the x. A 4 in front is going to be a vertical stretch by a factor of 4. That'll give us to negative 4 times 2 to the x. And now we have to apply the things from problem 1. So what this does is it stretches the function. A minus 3 is going to move it right 3. Negative 4 times 2 to the x minus 3. And then lastly, the plus 1 at the end will move it up 1. And that's it for 4.2. We'll do more Thursday. And lastly, I'm in the process of grading your tests, and hopefully they'll be done today or tomorrow.